Alright, this is going to be a review of Math 1010 Final Exam Form E from Fall Semester 2013. This is only a year ago, so this should be very similar to the final that you have in 2014. This review is for fall. Time limit 120 minutes, so you have 2 hours. ID verification, just so you know, when you go to a class it's your regular class, you probably won't have to put any ID verification there because your teacher will know who you are. But if you're sitting in somebody else's class for whatever special reason, then they'll need to check your ID. So that's what that is for. All problems are weighted equally, so everything will be on a same scale, same point scale. No graphing or programmable calculators, no notes, no books, no cell phones, headphones, any other devices that can connect to the internet. Nothing like that. What is allowed is scientific calculators with no more than a basic numeric store and recall memory. The exam is 2 parts. Part 1 is multiple choice. There are 10 questions. Make sure to answer all of them. And Part 2, 15 open-ended questions, meaning you have to show all of your work and your teacher will give you partial credit. So for Part 1, it's all or nothing, no partial credit. Part 2, show all of your work and make sure that you, so that you can get partial credit. 25 questions. This is still the same for your final. It's the same setup. Okay, and then it'll have instructions. Part 1, questions 1 through 10, multiple choice, answer all 10, circle the correct answer, there will be no partial credit awarded, etc. Alright, let's take a look at the first problem. So the first problem, a function of x is depicted in the graph. Looks like an absolute value function. Find any input values that produce the output of f of x equals 1. Alright, input x, output y. So they're saying output of f of x equals 1. Well, f of x is y. So they want to find all the x's where y equals 1. Now the line y equals 1 is, well, let's see if I can get it. There we go. That line. That's the line y equals 1. And we notice 2 spots where that line crosses the graph. Let me highlight these spots. They are points, like 1, 1. And this is -3, 1. These are 2 points that are on the graph. So again, this point and this point. Those 2 points have the y value equal 1. Now if you were to look at another point, like this point, that point is 4, 4. The y value does not equal 1. So that's not what we're looking for. We're looking for y values equal to 1. Output y equals 1. So we found 2 points where the y value equals 1. Now the question is a function of x, f of x, okay, find any input values, find any x values. Here we have our x values of the 2 points where y equals 1. So our answer should be x equals 1 and -3, these two, the x values of those 2 points. And that is how you solve this problem. I'm not going to spend any time on all of them in general looking over the multiple choice or circling them or whatever, because the key for like what are the correct answers is also given on this test. At least it should be allowed. But I'll circle them just for fun. Alright, next question. Find the distance between the points. So there are 2 basic approaches to this problem. One, if I were to take a look at where these points are, there's 3, 2, and -2 and -1. There's -2, -1. So the first method, find this distance. Well, this is just a right triangle. Now from -2 to 3 is 1, 2, 3, 4, 5. So we can fill out 5. And then from here to here, that's -1, 1, 2, 3, 3. So we just have a right triangle. And Pythagorean theorem says that, let's call this c. C squared equals a squared plus b squared. That's c squared equals 5 squared plus 3 squared, which would be 25 plus 9. So c squared equals 34, giving us c, or the distance, equals square root 34, which is great. Now I called it c because a squared plus b squared equals c squared is the Pythagorean theorem, as you probably have memorized. It might have been better to call it d, since this is an application of the Pythagorean theorem for distance, but whatever. And it's totally random that it ended up being multiple choice c as well. The other approach is the distance formula. D equals square root, parenthesis, x2 minus x1 squared, plus y2 minus y1 squared. The distance formula is awesome. And the only issue I ever see when I'm grading finals is people forget it, they mess it up, they have minuses where they should have pluses, they forget the squares. That's the main issue that I see, is people just don't remember it when they need it. Pythagorean theorem for me is much more likely to be remembered, so that's what I focus on when I'm working with students, when I'm teaching them. But this is fine. With this point, I would have that be the x2 and y2. Just so the first point's the first ones and the second point's the second ones. So let's see what we get. D equals square root x2. x2 is negative 2 minus x1 is 3. Again, x2 is here, x1 is here. The minus is the formula. Okay, plus squared y2 minus y1. y2 is negative 1 minus y1 is 2. That is y2 minus 1 minus, from the formula, y1 is 2. Minus 1 minus 2. Now we simplify on the inside. Minus 2 minus 3 is minus 5 squared, plus minus 1 minus 2 is minus 3 squared. Continue on the inside. Minus 5 times minus 5 is 25, plus minus 3 times minus 3 is 9, and we get d equals square root 34. So it's clean, it's pretty, and you've got to know the formula. If you don't, then I'd rather you practice the Pythagorean theorem, because that's all this is. The distance formula is just a fancy Pythagorean theorem formula. Okay, that completes this question multiple ways. Next question. Find the domain. All right, domain. All x values. So domain is the set of all x values. Now you can't always plug in anything you want into a function. So let me demonstrate by actually plotting some values. If I let x equal 0, I'd get square root of 4, which is 2. Great. If I let x equal 4, I get square root of 0, which is 0. Great. If I use 8, I get square root of negative 4, which is, at this point in time, you know it's 2i. But we're talking about real, so that is not in the domain. So what we see are square roots. Sometimes work, and sometimes don't. So to find the domain is to find all the values where it works. Now, some values will give you a square root of a positive number. Now, even if it's not a nice perfect square like 4, it still works. It gives you a real value. One number, usually, there might be more than one if you have an x squared somewhere in your problem, but one number usually makes your square root inside 0. This works. Square root of 0 is 0 because 0 squared is 0. And then there's a bunch of numbers we'll make the negatives in the inside, which is not a real number. So we want to get zeros or positives on the inside. So essentially we want to find where the inside is greater than, positive, or equal to 0. Well, our inside is 4 minus x, greater than or equal to 0. So that is, let's go through the steps. That is negative x greater than or equal to negative 4. And then dividing by negative 1, switches our inequality. Make sure you don't forget that. Going all over this whole problem and figuring that would really be a pain. We have x is less than or equal to 4. Now on a number line, there's 4. X is less than or equal to, looks like this. So that is negative infinity, comma 4. Hard bracket. Weird looking infinity. Anyway, B is the answer. So, in general, we want the inside of a square root to be greater than or equal to 0, and that'll solve all of them. In specifics, you might just see what value makes the inside 0, 4, and then figure out which side of 4 works, in this case the left side, and get it that way as well. Watch out also if it's a cube root. The domain is all real numbers because you can put in negatives inside a cube root as well as positives or 0. So all this work only applies for the even roots, square root, fourth root, sixth root, etc. The odd root domain is always all real numbers, unless you're doing story problems, then you might have real world concerns. All right, next question. Graph the system of linear inequalities. Okay, I'm going to start by plotting points, specifically if I let x equal 0 in this first one. If I let x equal 0, then I have 0 plus y equals 4. So that's y equals 4. If I let y equal 0 in this same one, then I would have 2x plus 0, 2x equals 4, or x equals 2. And what this does is it quickly gives me 2 points. Now with these 2 points, I then need to inquire into whether we have a solid line, like in this case, or whether we'd have a dashed line, as in the case of the other inequality. Since we have an equal sign, we're going to have a solid line. Now, my graph probably won't look good with this tablet, and I'm not using rulers, but this is our first line. Now, what this line really is the equation. We haven't talked about the less than yet. Alright, so if you hear some kind of strange noises in the recording, I'm in the basement of my parents' second house as I record this, and so they might be washing dishes or something upstairs. So, side note. Back to the problem at hand, we need to now figure out which side of this equation is shaded. Is it the upper side or the right side, or is it the lower side or the left side? And there's lots of ways, but the safest way is to test. I'm going to test 0, 0. When I plug this 0 in for x and 0 in for y, it will give me a statement. In this case, it gives me 0 less than or equal to 4. This is either true or false. So now I'm testing this spot right here. It's either true or false. In this case, 0 is less than 4. So this point, 0, 0, is part of the shaded answer. So therefore, we have below this line is shaded. Other people, other teachers might have had you solve and get it into slope-intercept form, not only to help graph it. For example, start at the intercept of 4 and then go down 2 and right 1. That would give you the same line that we have. But also, if you get it into slope-intercept form and it says y is less than, then you shade below the line. That's another way people do shading. Either way, this is the correct graph for this first 2x plus y less than or equal to 4 inequality. Next step. Y minus 1 is less than 0. There is something fishy about this equation. And what it is, there's only a y. There's not an x. I can solve for y. Let's see, get that right. Y is less than 1. So when you have an inequality or an equation where you're expecting 2 variables like x and y, but you only have one, then it's a special line, either horizontal or vertical. In this case, since it only has a y, it can only cross the y-axis. So the line that crosses the y-axis at 1 is a horizontal line. Now every point along this line will have y equals 1. And that's the only thing we really know about the equation form of this inequality is y equals 1. So it's the line that crosses through 1 on the y-axis, horizontal. However, it's going to cross through as a dashed line. We don't have an equal sign here. It's a dashed line. I'm going to do this one in blue. Dashed line, horizontal, so through the y-axis at 1. And should be straight, horizontal. That's, again, it's hard to graph for me, apparently. Okay, now what we need to do is shade it. This time it says y is less than 1. Well, those are the values below 1, so we shade down. Now, that line shades down everywhere. Now I'm going to go through with black and highlight the final answer. We've got a dashed line here. We have a solid line here. And the shading is everything below these lines. That would be your final answer. And I don't have the multiple choice because it took too much room, but you can match that up with the final answer. So when you're doing these linear inequality systems, graphing them, it's only what's shaded by all of the lines that is in your final answer. All right, next question. Perform the indicated operation and simplify. Write the answer in the form a plus bi. Well, first, quick check. All 4 of these multiple choices are in the correct form, a plus bi. I is on the right. And if there is a fraction, it's written in front of the I. That would be b. Now you might wonder, wait, this is minus. Why isn't it plus? Well, if b is negative, you'll simplify and have a minus. It's still in the correct form. Now we're starting with a real number 4 divided by a complex number 2 plus I. The way you divide by complex numbers is, this will always work, although there will be times when there might be a faster way, but this will always work. Multiply top and bottom by the conjugate. In this case 2 minus I. Only the conjugate of the denominator. The numerator is also complex. Don't do that conjugate. It's always the denominator's conjugate. Now, just so you know, and I'll erase this in a minute, what's really going on here is you are dividing by a square root. And we know you can't have square roots in the denominator if you want this to be rationalized. So then you multiply by the conjugate. And this is exactly what you learn to do when rationalizing denominator. All this really is rationalizing the denominator. Okay, let's see if I can erase that stuff. So a bigger eraser would be nice. There we go. So, to carry on with this problem, we've picked out the complex conjugate of the denominator, and now we have to FOIL things out. That would be 8 minus 4i on top. On the bottom, distribute. I said FOIL on the top, silly me. That would just distribute. And in fact, the bottom we distribute. We distribute this 2 to begin with, and get 4 minus 2i. Then we distribute this I, and get plus 2i minus I squared. Okay. Minus I squared is minus negative 1. It's plus 1. The whole thing is plus 1. Anytime you get an I squared term, you always want to change the I squared to negative 1 and then simplify. Because this gives us like terms in the bottom. Let's take a look. Let's do the right color. There we go. Let's take a look. On the top we have 8 minus 4i. On the bottom we have 4 and plus 1. Like terms makes 5. And we have minus 2i and plus 2i. Those go to 0. They're gone. In fact, you can see it. They're gone. So it's just 5. Now this is not standard form. Standard form, what you do is you split up the division and you put the I on the right. You have to make sure to distribute this divide by 5. So you distribute it to the 8 and the 4i term, and you get both of them divided by 5. All right, great. That's all there is to this problem. Next one. Perform the indicated operations and simplify. So we have fractions. There's one fraction, two fractions, three fractions. But what we don't have are any equal signs. There's no equal signs in this problem, which means this is not an equation. If you do not have an equation, you can't just simply clear fractions. You instead have to work with fractions. Now we have three different fractions, adding and subtracting. To add or subtract fractions, you'll need a common denominator. In order to see what the common denominator might be, you will likely have to take a denominator and factor it. So let's take a look what we have. We have 5 over x plus 3 minus x over x minus 6 plus x squared plus 30. And then the denominator, we're going to factor this into. Now, I'm going to take a wild guess, and say it's x plus 3 and x minus 6. You might think I'm taking chances, but I'm going to verify. There's our x squared. There's our minus 6 and plus 3 makes minus 3. And there's our minus 18. Very often you don't even need to think factoring in these finals because they're designed to work out because you only have 2 hours to take this whole thing. So they're designed to work out nicely. So you can look at other parts of the problem to give you hints on how to do the harder parts of a problem. All right. Now, we do not have common denominators. This only has an x plus 3. This one only has an x minus 6, whereas this has both. So that's going to be our common denominator, both. In fact, I can draw our new answer where it's all combined together with one common denominator. This is where we're headed. We're not there yet. The first one needs an x minus 6, so I multiply by a form of 1, a special form of 1. I know it's 1 because the top and the bottom are equal, but it gives me, you can see the denominator is in common. Done. The second one I need to multiply by an x plus 3. Notice I'm adding these extra parentheses around the old denominator. The old denominators were binomials, and once there's any other operation going on, you want to put a parenthesis around them so you make sure to do distributions and things you might need to do. All right, so now we're going to work with the numerators. I am going to distribute, and that will give me 5x minus 30. And watch carefully this one, distribute. And that'll be minus x squared minus 3x. And on the third one, since it already has the common denominator, we didn't do anything to the numerator. So that x squared plus 30 plus x squared plus 30 didn't change. Okay, get a little more room on this problem. Leave the multiple choice. We're almost done. We now have some like terms. First off, this x minus x squared and this plus x squared reduces. We also have a 5x and a minus 3x. That's a 2x. So that's 2x. And we also have minus 30 plus 30. Those reduce as well. So we just have 2x left over. How nice is that? X plus 3, x minus 6, and that would be enough for us to catch our multiple choice of A as the right answer. Now, we did not have an equal sign in the fraction problem, which means we can't clear fractions. Our answer, in fact, ended up with fractions because there's no way in general to get rid of the fractions unless you have an equal sign. Then you can multiply by the LCD and get rid of fractions. Those are, in fact, a little bit easier problems to work with, in my opinion. All right, next up. We're to number 7. Solve and graph. We have an absolute value inequality. All right, now absolute values on the inside of an absolute value could either be a positive or a negative or a 0. And now an absolute value does different things depending on what's inside. So if, and I don't know if it is, but if x minus 9 were positive, then we would just simplify and we would get x minus 9 less than 3. But if x minus 9 were in fact negative, then what the absolute value would do is kick in a negative x minus 9, still less than 3. So then if you multiply by a negative 1, both sides, to get rid of that new negative, then you get x minus 9 greater than negative 3. A lot of you might just know the pattern. The pattern is x minus 9 is less than 3, and x minus 9 is greater than negative 3. You have the same thing on the inside, x minus 9, so the left is still x minus 9. But on the right side, you either have what it is, less than 3, or you switch the inequality, greater than, and switch the number, negative 3. This will give you two inequalities to solve. Now on the less than problems, there's even a faster way than all of that, and it is to write the x minus 9 less than 3 and cookie cutter the less than symbol on the left and put the negative 3. This works for the and less than problems. Very fast. In fact, I always do it this way, if it's a less than. Because it allows us to very quickly solve for x. Now, since there are two inequalities, there's really 3 sides. So when you add 9 one spot, you have to add 9 to all 3 sides. This gives us an x is less than 12 and greater than 6. And that would be C. Really quick, really easy. Alright, so this is a compound inequality. Absolute value inequalities can always be written as compound inequalities. If it's a less than, it can be written in this condensed form. If it's a greater than, then you just have one and the word or and the other, and you solve it, and you get usually 2 separate answers. But this is one of the fast ones. We're moving on to the next question. Alright, Martha can rake the leaves in her yard in 4 hours. Her younger brother can do this job in 6 hours. He must get distracted easily. How long will it take them to do the job if they work together? This problem, the setup, might be something you just know how to do. 1 over 4 plus 1 over 6 equals 1 over t. That's the setup. Very simple, very easy. But you want to keep track that the together one is on the right. Since the question is how long will it take them to work together, we know the t variable is on the together side. Sometimes they tell you something about the together time, and you're trying to figure out how much on individually. So then your t would be on the left side. Okay, other people know it this way. The t on the top. This is also a familiar form. To explain the difference, obviously there's not much difference. If I were to take on the top and multiply by t, it would cancel, leave 1, and the t would show up on the top. So there, you can see they're the same. However, what this all is Martha can rake her leaves in 4 hours. That means each hour she can do 1/4 of it. So this is how much Martha can do in 1 hour. This is how much her younger brother can do in 1 hour, 1/6 of it. And this is how much they can do together in 1 hour. You don't know how long it would take them, so it's unknown. So this is her rate plus his rate equals their together rate. And that's a logical equation. Now when you multiply by t, what this is, t is time. If you take her rate 1/4, that's how much she gets done in 1 hour. And you multiply by t, that's how much she will get done of the job. So this is how much of the job she gets done. Her rate times the time. Now, distance equals rate times time. So when you take rate and multiply by time, you get distance. In work, the distance is how much of the job you did. So this is how much of the job Martha does, plus how much of the job her brother does, and then they get one job done. So these both make perfect logical sense, and now all that's left to do is how do you solve it? I don't worry too much about lowest common denominator. I just multiply by 4 and 6 and t. Because it works so fast. And you only have 2 hours, so it's nice if you can get this done fast. Or down here, just multiply by 4 and 6. Now 12 would be more, I don't know, socially acceptable, I don't know, whatever. But it just works really fast, so I don't worry about it too much. Either way, you end up with 6t plus 4t equals 24. That is 10t equals 24. Divide by 10, and t equals 24 over 10. Divide by 2, and that is 12 over 5. Divide top by 2, by bottom by 2, and B is the answer. All right, hope this helped. Next question. All right, number 9, solve. Where appropriate, include approximations to the nearest thousandth. We look at our answers, 0, 9/5, 1, no solution. Apparently we didn't need approximations. All right. I need to point something out first. This is gonna move this around. Whoa. Take a look at that 5. That 5 is not as tall as the top of the G, but it's close, but it isn't. It's also not the same size as this 9x minus 4, so this is not 5 times 9x minus 4. This 5 goes all the way down into the lower part of the log. This is not a nice way to write it, but there is enough evidence to see that that is base 5. Because if it were at the same level of the bottom of the log, then you would know it's not the base. But since it's lower than the level of the log, you know there's just a little bit. I like the whole thing below. But there's a little bit below. This is a base. It's the hugest base I've seen in a long time, especially looking at it like this. But that's a base. So this is not common log of 5 times. All right. So that being said, let's rewrite it the way I would have liked to see it. Log base 5 of 9x minus 4 equals 1. Solve. All right. How do you get rid of a log base 5? Logs and bases of exponents are inverses. So to get rid of a log, you use a base. A base is large and down to the left. So this 5 to the 1, that looks about like 5 to the 1 power. So the old numbers are now going to be power. So you have to make a bigger 5, and it has to be down in the lower left. So big 5 both sides is what my students tell me to do. That cancels out, cancels their inverse functions, so they undo each other. That gets rid of the log, leaving us 9x minus 4 equals, and 5 to the 1 is just 5. That's how you get rid of a log, with a base. The same base of the log is what you do the base of the whole, both sides. We can now solve for x. This is a much simpler problem. 9x equals 9, x equals 1, and we move on. simplify the expression. Now there's nothing too large as far as powers. 49 is 7 times 7. X squared is x times x. Y to the fifth. 1, 2, 3, 4, 5. When you have a square root, you don't see it, but this is a square root. When you have a square root, you're looking for pairs. Pair, 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 pair. These will all come out as singles. So we will have a 7 on the outside. We will have an x on the outside. We will have a y, and we will have a second y. But this little y stayed home. Okay, so this is 7x y squared square root y. And that's it. Make sure that you know that when you square root 49, you get 7. So 2 of them inside a square root reduced to 1 of them outside of the square root. And that's that. By the way, if they say this kind of stuff, assume that all variables are positive when they appear. Wow, I've never seen it quite like that. But that means that x is positive. So all that's positive, you don't have to worry about absolute values when you simplify this. Some of you might have remembered that from reading through the book. Next question. We are now out of the multiple choice. We're into the open-ended 15 questions. Partial credit, so make sure to show all work. Number 11, factor completely. All right, first thing about factoring is greatest common factor. Always look for greatest common factor. There's an x in common in both places, so I can pull out an x, leaving x squared minus 4. Next, you start to look for how many terms there are. What kind of pattern does the inside have? This is 2 terms. For 2 terms, you have difference of squares, which this is one of them. Sum of cubes or difference of cubes. Those are all the things that you know how to factor when there are 2 terms. If there were 3 terms, then we would factor like trinomials. If there are 4 terms, then you would factor by grouping. In this case, we have a difference of squares. So that is the x that we have, x plus 2 and x minus 2. Just make sure not to lose this x. The LCD, when you factor it out, remains outside. That's it. That's all there is to this one. It was a quick and easy one. Next question. Find the domain of the function. Okay. This function is different from our first domain, a domain square root. We had to worry about square rooting negative numbers and getting complex answers. This one we have a different problem to worry about. Specifically, if I were to put in 9, then I would get 8 over 13 times 0. That would be 8 over 0. You cannot divide by 0 in any number system, undefined. So you're watching out for a 0 in the denominator. Well, 9 causes a 0 in the denominator. So you can ask yourself, what makes that 0? And get 9. Then what makes that 0? And get negative 4. So x cannot equal 9. X cannot equal negative 4. And you can then call that good. It didn't specify set of all x's such that x is not equal to 9 and x is not equal to negative 4. That would work if you were really crazy. Some of you are. Oh, I got to use the negative first. You can put it in interval notation. This one's crazy because there's so many stops and starts. Obviously, the first box around that is the easiest. So what you want to watch out for is that you make sure you have not equals, not the equal signs. And also, what makes the top 0 has nothing to do with this problem. Only what makes the bottom 0 is to be interpreted in domain. Nothing about the 1. Sometimes if this problem is in multiple choice, you'll have x not equal to 1 from the top, and that's an answer, and people think, oh, that's got to be something. It's not. Nothing to do with the top. Only to do with the denominator. All right, great. Next question. Find the center and radius of the circle. Now, what's important about circles is their standard form makes it easy to get center and radius. To get standard form, we first group all of the x stuff together and then all of the y stuff together, and anything else move to the other side. All right. Next, you take the coefficient of the x and you divide by 2 and square it. That gives us 9. That's what you have to add to both sides to complete the square on the x squared minus 6x plus 9. Specifically, that'll now be x minus 3 squared. Where does the negative 3 come from? If you were to just reduce this inside, you get negative 3. That's always going to be this number. But then you square it and get 9, and that's always this number. All right, plus, again, you take the coefficient, in this case 16, plus 16, plus 16, and divide by 2 and square it. If I said 16 twice, someone came in and asked me a question. I paused it and forgot where I was. So we take the coefficient, let me just recap for my own benefit. We take the coefficient of the y and always divide by 2 and square. Same thing we did on the x, divide by 2 and square. That's always the operation you do to get the perfect number that completes the square. In this case, that would be 8 squared, 64. So we add 64 to both sides. All right. And that creates y plus 8 squared, perfect square. On the right side, this all adds and subtracts to 25. Wonderful. Now, to get the center, it's what makes this 0 and what makes this 0. So that would be the center is 3 comma negative 8. Again, what makes this 0 is 3. What makes this 0 is negative 8. Sometimes you just have an x squared. There's no x term, and so you just end up with an x squared, and then what makes that 0 would be 0. And to get the radius, you square root the 25. So the radius is the square root of whatever that number is. In this case, it reduces to 5. That gives you your center and your radius. All right, great. Next question. Find an equation of the line containing the given pair of points. The most common thing to do is to plug information into what's called point slope form. This form, you need to have the slope and you need to have a point. And you'll be left with a y and an x equation. So we have plenty of points. So I'm going to take the first one just so I don't have to think about it. That's going to be x1 and y1 when I plug it in. I can make that y look more like a y. What do you think? I can't even write. That's going to be my x1, y1, that first one. That's the sloppiest thing I've ever done. And now I'm going to make it look better. By just, now I've said that, let's move on. What we're missing is the slope. Well, we can do the slope formula. Plugging in our y2, which is negative 3, minus our y1 is negative 5, over our x2, which is 4, minus our x1, which is 7. That is 2 over negative 3. Watch out, the formula has a minus in top and bottom, so make sure you subtract. If you are subtracting a negative number, that will end up being plus. So there's our 5 minus 3 is 2. But if you're subtracting a positive number, then it is subtraction. 4 minus 7 is negative 3. That is our slope. So we now can go into point slope form and have y minus y1 negative 5 equals m negative 2/3 x minus x1, which is 7. And now some arrows to make sure you're knowing where everything came from. There's my x1, y1, and my m. Now we simplify. Y plus 5 equals, and here I'm going to distribute, negative 2/3 x plus 14/3. And now solve for y. Now why am I doing all of these extra steps? Because the instructions said write your answer as a linear function in slope-intercept form. So slope-intercept form is what I'm headed for, the y equals. So that's specifically y equals negative 2/3 x. Right, now here we have a fraction, 14/3 minus 5. Be careful with that, do your common denominator work, etc. You get negative 1/3. Your calculators can help you with that. There's lots of things you can do for the fractions, but hopefully you can just do fractions. Now, is that the final answer? The answer is no, it is not, because they said a linear function. Function notation is not y, but f of x equals negative 2/3 x minus 1/3. That would be the final answer. I just realized that I can draw on my menu. All right, perfect. So that completes this question. Before I move on, one thing that you can always do on a problem like this is to make sure that this line that you just came up with actually goes through the points that you just worked with. So for example, if x were 7, you plugged in 7, this would be minus 14/3 minus 1/3, which is negative 15/3, which is negative 5, which is what you should get. If you plug in 4, that would be negative 8/3 minus 1/3, which is negative 9/3, which is negative 3. Beautiful. It did go through. It is in slope-intercept form, and it is a linear function. We know this one's right. Feels great. Next question. Factor completely. This one has 4 terms. When you have 4 terms, you try factoring by grouping. I've grouped the first 2 and the second 2. In the first 2, there's a greatest common factor of y squared. Pull that out, y minus 6. In the second 2, now the first term of what I'm factoring is negative. General rule, if the first term is negative, factor out at least negative. In this case, there's also a 9 in common, so I'm going to factor out negative 9, leaving me y minus 6, which is perfect, because that now means we have a binomial factor, which is a greatest common factor. We can factor that out, y minus 6. And what's left over will be y squared out of the first one, minus 9 out of the second one. We've now factored it. This is now written as a product, so we know this is factored, but it's not completely factored yet, because we have this, which is a difference of squares. So we have y minus 6, and further, y plus 3, and y minus 3. That is factored completely. You could FOIL all this out and get all the way back to your y cubed problem and verify. You could also check like letting y equals 2 and use your calculator on the top one and then on the bottom your final answer and see if they give you the same result. There's some ways that you could feel good about whether this is right as well. Let's move on. Sketch the graph. Label at least 3 points on the graph. Give exact values for y. No decimal approximations. All right, it's time for a moment of watch out. Here we go. This x is not on the same line as the 4 and the 1 and the y, which means it's an exponent. This does not look good to me. I wish this were reformatted so that x were a little higher and a little smaller. But it isn't. So what we get is have to be very careful to recognize that that x is an exponent. If you were to graph y equals 4x minus 1 and it's in simple line and you get through this problem real fast and wonder why it's on the final, that's because you did it wrong. This is 4 to the x minus 1. That being said, now that we know it's an exponential function, we can be a little more careful with how we're working this problem. Exponential functions. First off, it says label at least 3 points, so let's do that. I'll plug in -2 and 0 and 1. -2, 4 to the -2 minus 1. That's 1/16 minus 1. That's just a little below minus 1. So at -2, we're a little below -1. Oh, sorry, a little above -1 because -1 plus 1/16. That's already really hard to graph. But there is a point there, right there. Plugging in 0, 4 to the 0 minus 1. That's 1 minus 1, that's 0. Point of the origin. Plug in 1, 4 to the 1 minus 1. That's 3. Now with exponential functions, there is an asymptote, a horizontal asymptote. In this case at y equals -1. That asymptote is the lower limit of this function. Sometimes it's the upper limit. In our case, we can see that this function's coming down through those points. Oh, that's going to be really hard to graph. Oops. Let's see. Hold on. No, but I'm not going to be able to delete that. Oh, I can undo. Yeah. Oh, it undid all sorts of things. Wow. Okay, I guess I'm just going to redo this graph. Okay, it's looking worse and worse. So when it's looking worse and worse like this, it's time to take your grade by the horns and make sure you get credit, even if your graphs are crazy like mine. Let's see, -2 and 1/16 minus 1 is -15/16. We've labeled everything. There's no way anyone better take any points away for this. All right, great. Now the -15/16, if you use your decimal to get approximations, well, you're not following instructions, so be careful with that. We've sketched the graph. We have a nice exponential. Exponentials have horizontal asymptotes. That's labeled. We've got 3 points listed. We are ready to go on. Next question. A projectile is thrown upward so that its distance in feet above the ground after t seconds is given by a function of g. What is the maximum height? All right, now I have 2 children, so anytime I see something, a projectile is thrown upward, I do not have a good visual of that, so don't be throwing anything up, so especially not during the final. What we need to do is recognize that this is a quadratic, t squared. This is a quadratic, and it's negative. If I were to ask you, can you graph a parabola that's a negative parabola, hopefully you'd be able to quickly say, oh, it looks something like that. This is the basic picture. They've shot a projectile, it goes up to the maximum and falls back down to the ground. The maximum is right here. That's the point that we're interested in. Maximum. The maximum will be some kind of time and g. G would be the height. Often this will be h equals, not g equals. It makes a little more sense, but g is fine, whatever. Well, this is all about the vertex. So for the vertex, there's a couple of ways that you might know how to find the vertex. I can go over 2 of the 3. I don't want to go over the third because it's a pain. But vertex, First off, you can go through the formula. X equals negative b over 2a. B being 360, so negative 360, and a being negative 15, 2a would be negative 30, and that reduces to 12. That's x. And then you go for y. Now I'm using x and y because that's what's going to come out of your memory banks when you're on the final. We'll go back and go, wait, it's not x and y, it's t and g, but we'll do that later. X equals, so y equals, if you plug the 12 into the function, this is how you find y values, plug values, x values in. This will simplify and give us 2160. Now, what's really going on, it isn't x, it's t. So t equals 12, and that is seconds. It's not y, it's g, it's height, equals 2160 feet. Seconds and feet come from the problem, t seconds, distance in feet. Now this question is, what is the maximum height? So our answer is 2160 feet. Sometimes they'll say, when does the projectile reach its maximum? And then we would say 12 seconds. This is probably the fastest way through this problem. Now if you find yourself understanding factoring really well, you can also had you factor this problem, factoring out the negative 15 t, then you would have t minus 24. This just means that at t equals 0 and t equals 24, the height is 0. So those would be your x-intercepts. And halfway between there would be 12. That would be a harder way to find x equals 12. Not too hard. And then you plug that into the function and find the y value. And then the third way, if you have lots of extra time on your hands, you can complete the square. And when you're done completing the square, you'll have that form. And in that form, once you get that form, it's very nice because you can see what makes t minus 12, 0 is 12, and the y value is 2160, and you can get your vertex very quickly. These are different ways that you can approach finding your vertex, but the most important thing that you want to take from this is when they're asking for maximum or minimum, and you have a t-squared parabola, it's the vertex. They should have just said find the vertex, but then it's not a story problem, and we got to put a few of those on the final just to mess with you. So, moving on. Simplify. Okay, we have a fraction, big fraction line. In the numerator, we have a fraction. In the denominator, we have fractions. So we have fractions inside of fractions. That would make this a complex fraction. So with complex fractions, there are two basic techniques to simplify. One is to work the problem till the top is a fraction. In this case, it would be 4x plus 2 over x. And the bottom is a fraction. In this case, it would be 2x plus 1 over 8. Then, invert and multiply said fractions. And then, simplify. In this case, we can factor a 2 out here and reduce those and get on the top 2 and 8, 16, and on the bottom x. I went over that kind of fast because the other technique is faster and I would rather focus on that. But this first technique, you get to add these two fractions together. So I put that over 1, then I multiplied by x over x and get 4x plus 2 over x. And on the bottom, multiplied that by 2 and got 2x plus 1 over 8. Then invert and multiply, and then simplify, in this case factoring, and get your final answer. A much faster approach is to look at all the mini fractions. Let me put this 4 over 1. all the many fractions, the x denominator, the 1, the 4, the 8, and get the LCD. The LCD is 8x, and multiply this by 8x, and this by 8x, and this by 8x, and this by 8x. What this allows you to do is to clear out all these little mini fractions, leaving you on the top with 32x plus 16 over 2x squared plus x. Then simplify. On the top, factor out the 16, leaving 2x plus 1. On the bottom, factor out the x, leaving 2x plus 1. And then being able to reduce and getting our answer of 16 over x. Both of these work just fine. It really depends on which method you're already used to, which one you should practice to prepare for this problem. Next question. Another story problem. There were 510 people at a play. The admission price was $2 for adults, $1 for children. The admission receipts were $720. Write down the system of equations which represents this situation. First off, we need some variables. I'm going to let A be the adults and C be the number of children. Write down the system of equations. Well, first off, the total number of A plus C, the total number of tickets were 510. That would be my first equation. Oops. Undo. Come on. It's not going to undo that for me. I can erase it. There we go. The second one, though, is the ticket sales itself. So that's the total number of tickets. The total number of ticket sales, $2 for every A, so 2A is how much we brought in the adult tickets, plus $1 for every C, or just C. That's how much money you'd make in the child tickets. That's going to equal 720. Now, because of I write too big for this space, I was not able to put these two equations above or below each other, and that's okay. Solve the system that you wrote down in part A. To solve this, they're already in standard form, so what I'm going to do is I'm going to multiply this one by a -1. So that'll be negative A minus C equals negative 510. And just write the other one below. 2A plus C equals 720. When I add these up, I get the C's to cancel, which is why I multiply the first one by -1. And 2A minus A is A equals, and 720 minus 510 is 210. That's A. Great. Now A is 210. Since A plus C equals 510, and A is 210, if we know A, we can plug it in and get C is 300. And that's the solution. So now we can say 210 adult tickets and 300 children tickets. Were sold. Now why add the word sold? Because they said a complete sentence. So I guess probably should spell out 210, but hopefully your teacher's not that kind of person and take a point off for that. But at least it's a complete sentence now. That is how you solve this system. You could have also chosen to do a substitution on part B. That would have been fine. But this one works well. All right, great. Next question. All right, there's been a system like this, 3x3 system, on every final that I can remember. I've been teaching for 10 years now or more. So solve this system. When you have 3 equations, and each 3 equations typically have 3 variables, in this case x, y, z, you want to boil that down into having 2 equations with 2 variables. Now, I already see, because the second equation doesn't have a y in it, it already has one of them eliminated. So I'm going to start by writing 5x plus z equals 4. Come on, give it the 5 looking better. 5x plus z equals 4. You might be used to these little scripts. That's R1, that's R2, that's R3, that's R4, etc. That's fine if you use those. I'll add those in, even though I'm clearly having trouble writing 2's and 3's right now. I'm trying to write too small. This stylus is not easy to work with. This is R4. 5x plus z equals 4. What makes this equation special is it has two variables, not three, so it's an improvement. We want to make another equation that looks just like this form, an x and a z. I do not want to find an x and a y equation because that would be useless in this case. I want to find another xz equation. So what makes this equation special is it has no z, because they gave us one with no z. Sorry, now I said that. Go back. What makes this equation special is it has no y. It only has an x and a z. It has no y because they gave us one without a y. Well, to make another one of these, we have to make one without a y, which means we have to take these two with y's and somehow eliminate a y. And I can see that if I took this times 3, there's that 3 problem again, try again. If I multiply this top one, come on, oh geez, there we go, by 3, I would get a minus 3y right there, and a plus 3y. That's going to work great. Let me make it a little bigger so we can see. 3x minus 3y plus 15z equals 63. And our row 3, x plus 3y plus z equals 1. If I add these up, I get this special thing happening. The y's cancel, and we get 4x plus 16z equals 64. Some of you might notice that you could reduce this by 4. Most of you won't notice that during the final, so to prepare you, I will do what I think most of you will do, which is leave it like this. That is another equation of the same form that we had. This would be like the row 5. This is what you need to get to, a 2 by 2 system. 2 equations and the same 2 variables. If you can get there, then you've reduced this problem to a simple problem you could do with substitution or elimination or all sorts of things. I see now I could eliminate the z's, probably the easiest, by multiplying the top one by negative 16. Distributing that through. That will be 56, negative 80z, so x minus 16z equals negative 64. And our row, so that's minus 16 row 4. Our row 5, 4x plus 16z equals 64. When we add these up, we get rid of the z. Hey, this time, not usual, we get rid of that as well. It's okay. We get negative 76x equals 0. So we finish solving for x, and we get x equals 0. We found x. X equals 0. What do we do with it? Well, we plug this somewhere into our 2 by 2 system. I'm going to plug it into row 4. So row 4, this was 5x plus z equals 4. We know what x is. That's 0 plus z equals 4. We have z equals 4. We now have x and z. I'm going to plug those into row 1. X minus y plus 5z equals 21. And x is 0. And z is 4, so 5z is 20. negative y equals 1, so y equals negative 1. Now we take these three and we put them together as an ordered pair. These problems take so much time, I highly recommend that you leave them for last or close to last, because they take so much time. If you use up a lot of time on this problem and make a little mistake and go back and try to find it, you will get frustrated. And that frustration will lead to anxiety, which will slow your brain down and get you thinking stressful thoughts instead of logic thoughts. And then the rest of the test gets longer and harder. Instead, put this off till last when the other problems had you already frustrated, and then you just, at the point maybe you don't even care anymore, and if you make a little mistake, okay, whatever, the fractions just keep moving. On a problem like this, from a teacher's perspective, it's easy for me to see that you basically know the process and you made a little mistake somewhere, and I can give you a high number of partial credit. But I can also see very quickly if you just didn't know what to do, or you were coming up with an xz equation and another xy equation and you were not clear about the process, and then I know not to give too much credit. So these are frustrating because you can make one little mistake and the whole thing seems to be out the window. On the other hand, they're easy to give partial credit for because I can tell if you're doing the right thing and made a little mistake. So do this towards the end. Don't waste too much time on these, in my opinion. Now, 0, negative 1, 4. You could then take 0, negative 1, 4 and come back up to this, and 0 here, and negative 1 makes 1, and 4 makes 20, and 1 and 20 is 21. 0 and 4, 0 and negative 1 is negative 3, and 4 is negative 3, and 4 is 1. You can go back and plug it in and check and make sure this one's all right, which this one is. Leave your answer as an ordered triplet. That's what an ordered triplet looks like. 3 numbers in the right order, ordered triplet. Okay, next question. Chuck and Dana agree to meet in Chicago for a business meeting. Chuck travels 66 miles in the same time that Dana travels 54 miles. If Chuck's rate of travel is 6 miles an hour more than Dana's, and if you let R be the rate that Dana travels, write an equation in R which could be solved to find the rate at which Dana travels. The important thing here is do not solve the equation. All right, do not solve the equation. We just need to set this one up. All right, well, they're talking about distance. They're talking about time. They're talking about rate. So this problem is a distance equals rate times time problem. And I'm going to set up, we have Chuck and Dana. Let's see what we can fill out. Chuck travels 66 miles. That one's just done. There it goes. In the same time, Dana travels 54 miles. Done. If Chuck's rate is 6 more than Dana's, and if you let R be the rate Dana travels, R. I'm not using capital because they have lowercase. I'm sticking exactly what they say. Now Chuck's rate is 6 miles an hour more. So Chuck would be R plus 6. And time, they didn't actually tell us. They just told us that they were the same time. So T for both of them. Now distance equals rate times time. Distance equals rate times time. We have a system, little 2x2 system. We can solve this for R and T. What do they want? Write an equation in R. So we need an R equation, which means we have to get rid of T. So let's take one of these and solve for T. And take that and plug it in for T in the other one. And this is substitution, and we get 66 equals R plus 6 times T, which is 54 over 54 over, oh, come on, pencil, there we go, over R. Done. There's an equation for R. Do not solve the equation. As far as I needed to go, and I'm going to get out of this story problem as fast as possible. By the way, anytime it's a distance rate time problem, I always set up this little table. and it gives me something I can solve with substitution or elimination very quickly. So this one was nice. We didn't have to finish solving. Had you finished, you would have finally solved for r, probably got two answers, one being negative, and thrown the negative away, and plugged that r back into one of these equations to find t, and then you would have known her speed, their time, and you can add 6 to her speed to get his speed, and whatever else they ask for you could solve. Let's move on. Solve. Square root problem. Now this is an equals equation. Oh, wrong color. I'm looking for my laser pointer. There it is. Equation. So with an equation you can solve. To get rid of a square root, we square both sides. You want to make sure the square root is all alone so you don't have to FOIL with square roots. Now the square root and the square reduce, so the left side is just 7x minus 3. The right side, 5 squared, is 25. Add 3. 7x equals 28. Divide by 4. Would divide by 4. All right, hold on. That doesn't make any sense at all, does it? How about, oh, now I can't erase. How about undo? Undo? Ah! Now it won't even let me undo. All right, fine. Divide by 7. I was already going ahead. My head already did 28 divided by 7 is 4. The 7's cancel. Sorry, guys. And x equals 28 divided by 7 is 4. Ah, this one was so fast, it won't take me much time to check it. Plugging in 4, that would be 28 minus 3. Square root of 25 equals 5. Well, it sure is. Can you imagine how fast this problem would have been had I not written that 4? All right, let's move on to the next one. Solve. Quadratic. Quadratic equation. I see the x squared, that's quadratic, and I see the equal sign. So with the quadratic equation, we want to get it equal to 0 and see what we can do. So if I just move everything to the left side, that minus 2 will be a plus 2 on the left. I can factor out the 2, squared plus 5x plus 1. Now, when you factor and it equals 0, you can then go to setting up equations. Set each piece equal to 0. Well, that's not equal to 0, that's gone. So we've gone to x squared plus 5x plus 1 equals 0. And that doesn't factor. But it still says to solve. So we're going to use the quadratic formula. The quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Let me give you a huge hint on doing this. Work out the b squared minus 4ac first. This is called the discriminant. It will tell you what types of solutions, etc. But it'll also, by working it out first, mean you won't have to keep writing the minus b plus or minus square root all over 2a 3 or 4 times. This speeds the quadratic function up so much. B squared, 25, minus 4ac minus 4 is 21. That does not simplify nicely, so we move to the quadratic formula. Opposite b, x equals opposite b, negative 5, plus or minus the square root of 21, all over 2a, which is 2. And we're done. That's it. Square root of 21 does not simplify. Had that minus 5 been a minus 4, you might have been tempted to cancel the 2 out. Don't do it. That 2 will only reduce if there's a 2 or an even number here. If there's a 2 or an even number here, then you have to cancel it out in both spots. Since there's no number here, you wouldn't, no matter what that was, you wouldn't be able to reduce, so don't do that. This is it. That was fast, easy. Quadratic formula is a lot faster if you work in the discriminant out first. Factor that in any way with a nice perfect square setup to help speed you up with the square root. All right, next question. Oh, by the way, on this one, you could have also completed the square. It takes a while, it's fractions, it's not very pretty, but it would have worked. Next one. Solve. This must be an equation. Yep, there's the equal sign. With an equal sign, we also have fractions. But equal signs make fractions easier to work with because you can get rid of fractions. But first, we have to find the LCD. So I'm going to factor this. Greatest common factors is x. So we factor out the x. X times x plus 1. Do not be surprised that it's the same as the other ones. So it means that our LCD is x plus 1. We multiply every term on both sides by this and see what happens. Reduce, 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 reduce. All fractions are gone. That's how you know you picked out the correct common denominator. What's left is, on the first one, we have x, and x is x squared plus 6 distributed in 6x plus 6 equals 1. This has no fractions. Definitely an improvement. It's a quadratic equation now. We just solved the quadratic equation on the last problem. You get it equal to 0 and see what you can do. So I'll subtract the 1 and we have x squared plus 6x plus 5 equals 0. I will attempt to factor this one. If not, I'll use the quadratic formula like we did before. 5 and 1, plus and plus. This makes a quick problem to solve, though, when it factors. We get x equals negative 5, and we get x equals negative 1. These are the two values that would make those factors 0. Having these factors of 0 means that when you multiply them, you would get 0. So x equals negative 5, x equals negative 1. We better check this, though. Check. I'm not checking this because I have extra time or anything. I'm checking this to make sure I don't make a stupid mistake. For x equals negative 5, we would have negative 5 over negative 4 plus 6 over negative 5 equals 1 over negative 5 squared. 25 minus 5 is 20. Work that out and it's actually true. But what's important is it doesn't do this. Check equals negative 1. We'd get negative 1 over 0 plus 6 over negative 1 equals 1 over negative 1 plus 1 is 0. Dividing by 0. This stuff, I almost called it crap, and now it's on video. Man, oh well. This crap is what you got to avoid. Do not divide by 0. Often, when you are solving these rational equations, you will find answers that make the denominators 0. That's really what you have to check for. X equals negative 5 did not make any of the denominators 0, so unless you made a mistake, that's one of the answers. But x equals negative 1 made these two both go to 0, and you can't do that. You might also recognize the x plus 1 factor was actually visible up here. So when it came to x plus 5 times x plus 1 equals 0, there's no way x plus 1 can equal 0 because it's in the denominator. That part of the answer is out, meaning our final answer is just the x equals negative 5. Rational equations, make sure you check. Make sure you don't have any answer that makes the divide by 0. All right, next question. All right, last question on this final, number 25. Graph the function. Label the vertex and at least one other point on the graph and draw the axis of symmetry. Write the equation of the axis of symmetry. Now, first off, notice that whoever wrote this cannot spell symmetry. Poor guy, didn't even see it. Hopefully I wasn't reviewing this final because I missed it too. All right, here we go. Quadratic functions, x squared, y equals x squared essentially. This is a parabola. So parabola's vertex. Let me fill that in so it looks like a point. There we go. That's what we're actually after. Now, in standard form, you can just see the vertex. What makes that 0 is negative 4 and then if you plug in negative 4, y will equal 2. So this form, we can very quickly get the vertex. This is the completed square form. This is the best form to have, although it's not always worth getting to if you don't have it, because it's kind of hard to complete the square on some problems. But if it's in this form, just very quickly get the vertex. Negative 4, 2. It puts the vertex right here. Now that I know basically where the vertex is, I'm going to go one step away from there and try negative 3 and plug it in to get my at least one other point. Negative 3. Negative 3 plus 4 squared plus 2. That would be negative 1 squared plus 2. That is 1. Negative 3, 1. Negative 3, 1. The symmetry gives us this negative 5, 1 as well. Label the vertex. Label negative 4, negative 2, and at least one other point. Negative 3, 1. Negative 4, 2. Sorry, not negative 2. So we've labeled those. Draw the axis of symmetry. The axis of symmetry is right down the middle through the vertex. That would be crossing the x-axis at negative 4, so it's x equals negative 4. Write the equation of the axis of symmetry. We've done everything they asked for. We have graphed the function, nice parabola. We've labeled the vertex and at least one other point. And we've drawn the axis of symmetry and gotten the equation of it. So it's very nice when it's in this form. Just briefly, had it been y equals negative x squared minus 8x minus 14, which is actually the same, I just foiled in my head, then we'd have to go after negative b over 2a for the vertex. And that would have been 8 over negative 2, which is negative 4. And then we'd have to plug that value in and simplify, and that would have been 2. That's how you would have to find the vertex if it's in the standard, or the general form. So whichever form it's in, you want to very quickly get to the vertex. If this is a graph parabola, graph function, quadratic function, you want to get the vertex quickly. If it's in this standard form, the vertex is so easy. Make sure you recognize it. If it's in general form, make sure you have your formula approach to quickly get your vertex. Then plot another point. Close by though. Once I knew the vertex was over at negative 4, I would go to like negative 3 or negative 5. I wouldn't use 0. If you plug in 0, you're going to be down at 14. You're going to be off your charts. So plug something in close to the vertex. Axis of symmetry is the x value of the vertex. X equals negative 4. And then you're good to go. All right, that completes this review of this final. I hope it helps.